Hey everybody, welcome back to Java A to Z Fundamental Speed Training with Coding Nomads. My name is Ryan Desmond and this is part 3 of our 90-ish minute speed training. So if you haven't already seen parts 1 and 2 where we covered data types, variables, operators, arrays, object-oriented programming briefly, classes, objects, methods, etc. That's sections 1 and 2. Please refer back to those. This one will make a little more sense. This one's a doozy. This is 3 of 4, and the 4th section is where we're going to go over a Blackjack game that we're going to make together. But in this section, in the next roughly 30 minutes, I'm going to talk about interfaces, exception handling, input-output, multi-threading, generics, enumerations, and Lambda expressions. And this is quite the challenge, but I'm going to give it a go. So in the last video, we ended off talking about object-oriented programming, and the one thing that we weren't really able to talk about there was interfaces. So I want to jump right into interfaces. And I'm going to just demonstrate what that is. So let's say I'm going to create an automobile interface. And an interface is just like any other class, except for the methods don't have a body. They're abstract methods. So one of the things I'm going to do here, let's say that every single automobile needs to have the ability to accelerate and decelerate. And these are going to take in, let's say, int mph miles per hour to decelerate and int mph miles per hour to decelerate. And that's it. This interface is now done. And you know, it's just the keyword interface instead of class. And our methods are called abstract methods, meaning they do not have a body. And now if I go back over into section 2, under, go look at this vehicle class that we made, I can now say vehicle, public class vehicle implements automobile. And this is going to be, I'm going to have an error right away because when I have an interface, if somebody implements that interface, so it's kind of like, it's not extending a class like a parent class, it's implementing an interface. An interface is kind of like a contract where, let's say at this automotive company, the CTO or CEO says every single automotive car of any kind, automobile that comes out of this software group, out of this plant, needs to implement the automobile interface. And if you implement the automobile interface, you are required to implement the methods that were defined in the automobile interface. So in this case, accelerate and decelerate. In this case, since vehicle is kind of like a parent class, we have another option where I can declare this class as abstract. And so abstract means that I know that I'm supposed to implement these methods or these abstract methods in the automobile class, but I'm not exactly sure how to deal with it yet. So I'm going to have any class that extends me implement those methods. So for instance, in my class motorcycle, I've got to implement these methods. So all I did there real quick just to show you is you can type them out by hand, or you just put your cursor over the red arrow here, take that little light bulb, click implement methods, choose both. And you'll see that it puts these 2 blank methods in here. And I'm just going to say, you know, accelerating motorcycle and decelerating motorcycle. I'm going to also just copy over these 2 methods because I know I'm going to need it. And again, we're using @override. So this goes into the polymorphism with object-oriented programming, along with overriding the method in the parent class or overloading a method multiple times, such as system.out.println. We can use the same kind of override override polymorphic activity or behavior is also present for interfaces. So if I go over to my sedan class, I'm going to have that same error until I implement those methods. So here I would say implement sedan accelerate sedan, decelerate sedan. And now when in my OOP controller, if I was to go back over here and just go ahead and bring these objects back into play. So this should be things are changing around a little bit here, but I'll just fix it to make it work. Here I can say my car dot accelerate 10, and I could say motorcycle. Do I have the motorcycle? I've got bike Byte.accelerate 20. And when I run this, you'll see that I have the same method accelerate, but in one place it'll say that the vehicle is, or sorry, the accelerating sedan and accelerating motorcycle, meaning that that method is, we define it both the sedan and both the motorcycle because they're going to accelerate in different ways. But it's a requirement from the manufacturer, from our boss, from everybody, that all vehicles must have the ability to accelerate and decelerate. So that's in many ways where interfaces come in. They have other uses too, but the core thing that you need to understand about interfaces is that instead of class, you say interface, and you have methods that are called default methods. They have no body. And any class that implements, which is the key word for using interfaces, any class that implements an automobile must either fill out those methods, override those methods, and give them a body, or declare itself as abstract, which then just punts that responsibility down the line to, for instance, motorcycle and sedan, which both extend vehicle. So that's interfaces in a real hurry. Let's move on to exception handling. So what happens, I mentioned it earlier when, let's just go ahead and close others. When exceptions happen, right? We don't like exceptions. They kill our program. So I'm just gonna do really quickly for an example. I'm gonna make a public static int divide method, and it's gonna take in 2 arguments, int a and int b. And then I'm gonna return a over b. And right here, I'm just gonna say int result equals divide, and I'll say 30 divide comma 0. Those are the 2 arguments I'm gonna pass. Or let's just do 30 divided by 5 first, and then I'll sout result equal plus result. When I run this, it's going to print out result equals 6. That looks great. But what happens if I pass in 0? And keep in mind that when we're writing methods like this, we're usually not the ones that are consuming them. We're like, sure, sometimes we write methods that we call, but this divide method in my company, there might be 50 other people in the company that end up calling it, let alone open source. Could be thousands of other people out there in the world that end up calling this method. I've got no control over whether or not they pass 0 as the denominator. So what happens when you do pass 0? You get an exception. It's called an arithmetic exception, division by 0. Java doesn't know how to deal, it doesn't know how to handle this, right? So this is, and when we get an exception, and notice how nothing printed out afterwards. We didn't get the result equal, like out here in the output, there's no result equal this. It just killed the application. And that's a bad thing, that's a bug. We don't like our applications to do that. So what we can do is basically say, try and catch that. So we're going to try to do something, but in this case, we know it's an arithmetic exception, that this is the data, the object type, that it's just an exception. This is the name of that exception object when it comes in. And then I could just say, like, you know, sout, there was an error. And then just go ahead and, this isn't what I really want to do, but for demonstrative purpose, I'll say return 1 or return 0, let's say. So when I run this, it's going to print out there was an error, and then say result equals 0, right? Because this method must return something. It's in its method signature, it says right here that it returns an int, but an error happened, right? In this case, we're not sure what we should return. Is 0 the right thing to return? No. Is 1 the right thing? No. Is -1 the right thing? No. We don't know what to return. So then what we actually should do is throw this exception up to the calling method. But watch what happens now when I run it. Basically, I'll get that error again. Say there was an error that printed out here, and then I threw this exception, which is called AE, back up to the main method, to the method that called me, that called it. But right here, we're not handling it. So what I would do here is I would say throws, because I'm not sure what I'm supposed to return if there's an exception. If there's an arithmetic exception, I don't know what to return. Should it be 0? Should it be 1? I don't know. So I'm going to say that I have the option, the potential of throwing an arithmetic exception. This method does. So now when I call it, I know that when I'm calling this divide method, it's like, shoot, this can throw an arithmetic exception. I need to try to do this. And then catch that arithmetic exception that it throws. I'll call it AE again, and I'll just say sout, there was an exception. Division by 0. And then I'll just to prove that it does not kill the program, I'll say all done. And run it again. There was an exception, division by 0, all done. So this demonstrates that even though we did divide by 0, and this method, this is where it happened right here, this method throws that exception back up to the main method, and the main method must catch it or throw it itself. But there's nowhere for the main method to throw it except for back to the JVM, which basically means that it's an exception. So this is a try-catch statement. This is the primary way we handle exception handling for actual exceptions. They say exception handling is for exceptional cases. So don't just rely on an exception handler to solve all your problems. A good thing to do here would be potentially do some data validation, make sure that a user doesn't pass in 0, something. But here, if that arithmetic exception happens, we're going to catch it. There will be no exception. Our program will not crash, and it will continue moving forward. So the 4 primary keywords with exception handling are try, catch. And then there's finally. One last thing is I'll show you is that finally, you'll see, finally says whether either way I will print. And I'll just demonstrate this real quick again. So no matter whether the try works or the catch happens, whatever's in the finally will execute either way. So that time there was an error. This time there will not be an error. And either way, what's in the finally block will print. Either way, I will print. So that's finally. There's also a try with resources, which we're going to talk about really briefly when we talk about I/O. But this is try, catch. Finally, you see sometimes it's optional. Try, catch, finally. And then throws and throw. So you can manually throw an exception the way I did it before I put throws in here. You can just say, for instance, I could throw AE, which is the name of this exception, back up to whichever method called me, actively throw it. But there's nowhere to throw it from the main method, so I wouldn't do that. But if it's throws in the method signature where you want to indicate that this method has the potential to throw an exception. Really quickly with exception handling, I'm going to show you what you can make your own exceptions all the time, custom exceptions, so really easy. This is just some custom exception. I'm going to say extends exception. I don't have to do anything else. That's it. But over here, I could say I'm going to demonstrate public static void throw custom exception. And I'm just going to say throw new custom exception. And then in that exception, I'm actually going to give it a little error, like a little name, I am a custom exception. I'm going to, in the custom exception, because I want to give it a little name, I'm going to give it a constructor where I pass that directly up to my parent class. So I'm going to say super. I'm going to call the parent constructor in the constructor class, and I'm going to pass in this string message that I'm going to take right here. I know that the exception class has a constructor that takes a message. There it is right there. And it sets the message of what that error is. So in this custom exception, string message, super message. And then I have to say that this throws custom exception. And then up here from my main method, I'm just going to demonstrate throws custom exception. I have an error right here because it says that I have an unhandled exception. So what I need to do is just surround with a try catch. And I'm going to say, instead of print stack trace, I'm going to say get message. That'll show you our little message. So it's going to print out all done. And we did not get the message. Right, because I need to print it out. And we'll run that one more time. There we go. So it printed all done as we expected from this line. And then it said throw custom exception, which is just me calling this little method I'm creating just to demonstrate throwing a custom exception. Immediately just throwing that exception and giving it a little message. This is the custom exception. It's that simple. You really don't have to do anything else. And this could be because, let's say that like we have arithmetic exceptions and array index out of bounds exceptions and all these file not found exceptions, all these things that Java and all these other people have created. But sometimes we need our own exceptions. Like, like let's say that this is ID for a bar in the United States, and you can have a not over 21 exception or something, you know, like where just because someone has age 20 doesn't make the program crash, but it does mean that, you know, for instance, in this particular case, like you can't do what they were trying to do. You can't sell them alcohol. So you can create like a custom exception called under 21 exception, and it could have its own message and do its own thing. So you can create custom exceptions whenever you need. That's exception handling in a hurry. Input output. So input output means let's read and write some files. So PSBM, there is two types of streams. We have byte streams and character streams. Byte streams are for bytes, raw bytes. Raw bytes are just things like raw data, such as numbers, images, you know, just anything that's not a character in a human language. So zeros and ones, basically. Anytime you want to deal with I'll say numbers, images, etc. Anytime you want to deal with human language, you need to use a character stream, because a byte oftentimes is not enough information to hold an entire character. So a byte is 8 bits, and many characters in a variety of human languages, the characters require 16 bits to be represented in a computer. So if you need to parse the file that you're reading like a human, like that's readable, you need to use a character stream. You can tell that you're always dealing with a byte stream because you'll see the word input stream or output stream. You can tell that you're dealing with a character stream because you'll see the word writer or reader and or writer on the object that you're creating. So let's go ahead and create one. So I'm just going to say file input stream FIS equals new file input stream, and I'm going to give it a path. Let's go back over to the command line. Let's just go ahead and vim a file. So this is file.txt. And I'm going to say one Ryan coding nomads. And then we can go like 2 Kim coding nomads. 3, I'm faking like a CSV file here. Let's go with Katie nurse. You know, and this is just an example of a quick file here. I just wrote it. I'm going to copy this path. I'm going to pop it in right here and then say file.txt. File input. So the moment we start dealing with input output, we start dealing with a lot of exceptions, because what happens if that file is just not there? So this is our application reaching outside of itself for the first time. So there's a very good chance that we could give it a path to a file that doesn't exist. So we can do a couple of things. We can surround it with a try catch, like we've done before, like we just did. We can add throws to the method signature to throw that exception, or we can use a try with resources. And I like the try with resources a lot, because the try with resources will basically, it'll automatically catch, will automatically open and catch the, close the connections that you're opening, sorry. So when we open connections to files, we need to close them and oftentimes flush them. And the try with resources will automatically do that. So it means we don't have to use the finally block. I'm gonna keep moving forward. I'll say file not found. Is that the exception? File not found exception. FE and do something with it. So there's a couple of, I think we could probably just go with the, can we just go with that? Yeah, we can just go with the IO exception. If I was not to use a try with resources, so I'll just go ahead and copy this because I'm gonna come back to it real quick. If I was not to use a try with resources and I was to just kind of, try with resources is new in Java 8, and I was just to create this and put it, for instance, in a try catch, it's a requirement that I do a finally, and where I say I have to declare the file input stream now outside of here so that it's available in the finally. And then I have to say fis.flush or fis.close. And then this also has a, There also can be an unhandled exception here because FIS, there could be another IO exception. So we actually have to catch another, so I have to put this in, I'm looking for my light bulb here. I'll just do it manually, try catch IO exception, IO. And then you have to, for instance, like something happened. And this is all super tedious. I haven't done this in a while because we don't have to anymore. So now that we have the try with resources, we don't need to have the finally lock where we close everything. So what we can just do is say try, and then in parentheses, we say file input stream, FIS equals new file input stream, get rid of this, open up a curly, and unhandled exception, we need that to be an IO exception. So now what I'm going to do is I'm going to say int val equals FIS dot read. Or you could say something like while FIS dot read does not equal -1, because this read method, it'll return the code of -1 when it's reached the end of the file. So I'm going to say while FIS.read does not equal -1, or I can say like, how about we create this val here, int val, while val equal FIS.read, handle this exception here. Okay, just doing a little cleanup here. Val, we need to double wrap this. Then I can say, for instance, sout val. And let's see if this works. So there was a lot that kind of went in there, but basically this is a try with resources file input stream. I directed it to this little text file that we created. It returns a byte of data, this read method, or a -1 if the end of the file has been reached. So I'm basically saying, while val, I'm doing two things at once here. I'm saying FIS.read, and this, just so you know, when I hold down the command key and hover over any method or class and click on it, it'll take me right to that method. So this returns an int. So I'm basically saying, well, int val equals whatever FIS.read is, and that's inside its own parentheses. And while that does not equal -1, keep going and print it out. So this, we basically should see this will all run out in one line, but we should see the contents of that file. But again, remember this is a byte stream. So we're just seeing the integer values of those numbers. So what if I wanted to actually deal with that, see these characters? Then I would say file reader equals new file reader. And again, the difference between a file input stream and a file output stream is that one is a byte stream that deals with bytes and data and images, raw data, and one's a character stream that deals with characters. And the other thing I'm going to do here is I'm going to say char val. Let's see if that'll work. No. If I cast this into a char, I think that'll work. There we go. There's the actual data from the file. So file input stream is a byte stream. File output stream is a character stream, or sorry, file reader and writer are character streams. File input stream and file output streams are byte streams. Something to make it extra confusing is that there are lots and lots of different stream readers. Let me go back here. These are just for the input streams. We have file input stream, buffered input stream, piped input stream, sequence input stream, so on and so forth. And these are, we have input streams to read in and output streams to write out. And then with character streams, we have an equal, basically, group, an equally large group. Try not to let it overwhelm you. Just know that they all basically act the same way. One other difference. So right here, we're reading character by character. What if we created a buffered reader? A buffered reader, so right now we can only read 1 byte or 1 character at a time. But what if we want to read a word or a sentence at a time? So then we need to create a new buffered reader. To do that, I'm going to say buffered reader, BR equals new buffered reader. And then as an argument, the buffered reader actually takes a character stream. So I'm going to pass in this new file reader, just like we had it before, but I'm going to pass it into an argument to this buffered reader. And here now, instead of, I can say br.read, but instead of that, I can say br.read line. And now I can read the whole, let's see here real quick. There it is. Oh, because this needs to be a string. Let's see what read line returns. Read line returns null if the end of the stream has been reached. So that should work. And then I can get rid of this casting. So now I can read, basically a buffer just takes in byte by byte by byte or character by character by character and allows you to read it line by line by line. Oh, I should say, well, not get the inverse there, because basically I'm saying to do that while it's empty. Null pointer exception. So I'd have to deal with that, but in the sake of time, I'll keep moving right now. You can do a buffered reader for character streams, or you can also do a buffered input stream for buffered input streams. So input output, just reading and writing from files, character streams, byte streams, and then buffers that you can put either a byte stream or a character stream into if you want to read more than one byte or character at a time. Moving forward, multi-threading. Close out all these, close all. Multi-threading. There's a couple of ways that we can do multi-threading. The recommended way is to implements Runnable. Runnable is an interface that has only one method that you must implement. And I can just say implement methods, and that method is called run. And run is what will happen inside, like basically you need to the run method is the only method that you need to implement in order to get this thread running. So in order to implement Runnable, the Runnable interface still uses, and we can go look at the Runnable interface real quick. You can, here it is. It's a functional interface, which we'll talk about at Lambdas. But it has one abstract method called run. We're still going to use a thread. So I'm going to say thread. And inside this, I'm also going to create a constructor. And this is going to be called implementing Runnable, public implementing Runnable. And why don't we take a string name for this thread? And I'm going to say thread equals new thread. I'm going to pass, because I know that the thread constructor has a parameter that takes in a name of the thread. And then I'm going to say thread.start. And 100%, we're basically done there. We could just say, I'm going to say for int I equals 0, I less than 10, I plus plus. First thing I'm going to do is I'm going to say thread.sleep because I want this thing to take a while. So I'm going to have each loop sleep for 2 seconds. So that sleeps in milliseconds. So this can cause an exception. So I'm just going to put it inside a try catch. And then I'm going to say sout thread.getName. And then I'll say plus on loop number plus I. And that's it. So when this method is called, when thread.start is called inside the constructor, and you don't have to put this in the constructor, you can do this elsewhere. I like to just automatically start my threads when they're created. When this thread.start method, the thread class itself will call this run method that we're overriding in here. So let's go ahead and create an example of that. So PSVM, and I'm just going to say this guy's called implementing Runnable. I'm going to call it Runnable1 equals new implementing Runnable. And let's give it a name, which is Runnable1. And then I'm going to do that a few times. And these, when I create these objects called Runnable1, Runnable2, and Runnable3, they will run on their own thread, meaning they can run in parallel. We're already working on a thread when we're using Java. We're just working on the main thread. but we have the option to run on multiple threads. So when I run this now, you'll see that they all just kind of forgot that I need to pass in the this. This is a little funny, but I basically need to give it the runnable that it needs to run. So a little oversight there. I'm going to stop that, and I want to fix, make sure runnable 1, runnable 2. Okay, so now we'll start from scratch. So you see runnable 3 on loop 0, runnable, they're all running in parallel. It looks, and there's no real guarantee in the order that they'll come out. 3, 1, 2, 3, 1, 2. They're sticking to the same schedule right now. 3 is 3, 2, 1, but they don't need to because all of these threads are running in parallel. That's implementing runnable. We can do that in a number of different ways. You don't have to put the thread in here. You don't have to start the thread in here. But that's a very simple way to do it. Anything that you put in the main method is the run method is basically like the main method for the thread. You can call off into any other methods, make any other objects, classes, do whatever you want inside this run method. This is just where it starts, much like the main method. We can also extend thread if we want to create a thread. Extending thread, in Java, we can only extend one class, but we can implement many other classes. So we don't like to use our one extension unless we really need to. And the only reason we would need to extend thread is if we needed access to the public or protected variables or methods in there, which we usually don't. So implementing runnable is usually better. So again, I'm going to say public. I'm going to create a constructor. Since we extend thread, I'm just going to extending thread. There we go. I'm just going to call super. And then I'm going to call, I'm going to give us a name in here again too, string name. And let's say pass up the name. And then we're just going to say start, because we don't need to say thread.start like we did in the implementable, because we are the thread. We're extending thread. And then again, we just have to override the same method, public void run. And then I'll just take the same code that we had in here and put it in here. And instead of saying thread.getName, I can just say getName, because getName is a method on the thread class that I have direct access to because I extend the thread class here. And if I run this, instead of implementing runnable, let's just comment that out. I'll say extending thread 1 equals new extending thread 1. And I'll copy that a few times. Make a few of them, 2, 3, 2, 3. And now when I run this, it'll act in the same exact way, basically. Or at least it should. There we go, thread 2. See how it's thread 2, 1, 3, 2, 3, 1, 3, 2, 1. This one's doing good. They're all coming out in different order because they're running in parallel. This is really powerful. If you need to do something in sequential order, you don't use threads. But if you don't need to do something in sequential order, you don't have to. You can do things in parallel by using threads. And so that's multi-threading with Java. It's pretty simple. And I'm going to keep moving because we're low on time. Generics. So a generic class basically is, I'll make let's say that I've got a method that, like that math one, public int multiply, and it takes in an int a and an int b, and it returns a times b. Go ahead and create a quick little controller here, generics controller. And I'll create a quick little main method. Here I can say generic class dot, let's make this static. I can just say, int result equals generic class dot multiply 10 and 2, and then sout result. right? This will work. We're used, this makes sense. It's just some class called generic class. It's got a static method called multiply, returns an int, takes 2 ints as arguments, returns a times b. But now this multiply method's great and all, but it'll only work for ints. So how do we make it work for doubles and floats and longs and everything else? Is we can make it generic, and we can do generic classes or generic methods. We'll start with generic classes. So right here, basically, all we do to make a class generic is that we say, well, this is, for this multiply method actually makes more sense to do a generic class, but let's just make another method, public static void. And there'll be some kind of generic type, and we'll just call it val, and we'll make this a generic class. So to make a class generic, right at the class definition level, you say in diamond brackets something like E or N or T. There's often, there's a lot of different ones. But when you create this generic class, okay, so let's make this non-static now so we can play with this. When I create an object of this, so where's my generic controller? When I say generic class, and I can make it of type, let's say integer, generics don't work with primitive types. Fortunately, we have these things called wrapper types, which are just an object type, such as integer, double with a capital D, float with a capital F, that wrap our primitive types and give us a little functionality, like we can use them with. And I'll call it gint equals new generic class. And you used to have to put the diamond bracket like integer on both sides. You don't have to anymore. So it can infer that. So then I can say, for instance, gint dot print me, and I can pass in an integer. E. I'm gonna make a constructor here to make this really simple. So when I can pass in like an integer right here. So I'm calling the constructor, and I'm passing in an int. And this time it's a v, and it just says this dot val equal val. It sets this variable to that argument, and then I have this method called print me, which just prints that out. So this will work, right? But what's cool here, so it printed out 10, is that I can do this again, but I can change the argument type. So let's make this a double. Call this dint, and this will be 10.123. Yeah. And I can do it with, let's do with how about a long? And we'll call this elent. And I can run this, and this class and this method print me will work for all of them because this class is generic, right? So when I created this class, I said the generic type E right here is going to be an int in the first case. And then in the second case, it's going to be a double. In the third case, it's going to be a long. But these are all like this, all of these class objects exist kind of at the same time, right? So it's not like I'm replacing one with the other. Like down here, I can still say gint dot whatever. I can still just use it. But the class is generic, so I can use it with multiple different data types, right? So that's a generic class. I should say that when you create an object of generic class and you say what the data type is, like integer right here, everywhere where you see E, it will be, in terms of the byte code, it will be replaced by that data type. So it would look like kind of like this. This is kind of what the JVM sees. The JVM doesn't see the E. So now let's talk about a generic method. So I'm going to go ahead and, well, yeah, I'll put that. I'm going to take this out and E. So that's a generic class. Let's go look at a generic method. So you can, beyond generic classes, you can also have generic methods that are not in generic classes. So what I can say here is I don't know what A is going to be. I don't know what E is going to be, right? And I'll just for simplicity. And then right here, we're just going to say E, and I'm going to say extends number, and that's called a bounded type. And A dot double value and B dot double value, and I'll make this thing return a double. So now this generic method, so if I go over here into my generic controller, wherever that went, I'm just going to get rid of these guys for a minute. Now I can say generic methods, and let's make this first one an integer. And let's call it gmeth equals new generic. Oh, it's not, sorry. It's not a generic class, so I don't have to do that. Equals new generic methods. And then I can just say double val equals gmeth dot multiply. And I can pass in basically any two numbers I want, like 10.2, comma 31.567. That's going to work. So I can say sout val. And then let's just do this again, but to demonstrate that it works with multiple data types, let's just do this one. It's going to be val2. This is going to be gmeth2. This one I'm going to do ints like 2 and 4. This is 2. So it's still returning a double, but I can pass it ints, I can pass it longs, I can pass it floats. So I can put it 2 Fs on here. That means it's a float. Still going to work. So that's generic methods. So we have generic classes, which just, you have this diamond bracket up here. When you create a generic class, you have to indicate, such as we did right here, what the type of that generic class is. And this integer, like as it is here, generic class in the diamond brackets, will replace E everywhere it's found in the class. A generic method, we can have basically parameters that are generic. And in the beginning up here, before the return type, we have to define any bounds about that generic type. So in diamond brackets right here, I just say E. It's just the syntax of a generic method. But I can say that E must extend number. So that means I know that I can do it, because all the number classes in Java extend the number. So that means I know I can do some kind of numeric thing like multiplication on it. That's generic classes and generic methods. Moving over really quick, enumerations. Enumerations are kind of like lists, and they're useful for, so a simple enumeration could just be like, so let's, I'm going to change this to, let's call it, I'm going to refactor this so it makes a little more sense. Refactor, rename, and I'm going to call this color enum. And enumerations are called enums for short all the time. And this is just going to have a couple of things like red, blue, yellow, and we can leave it at that. It's done. It's kind of like a list. And then in my enumerations constructor or controller, enumerations controller, I can basically just use that enum. So PSVM, and I can say color enum red equals new color enum dot equals color enum dot red. And this, we use enumerations when we have a list of things that's never going to change, like the months of the year or the colors of a rainbow, or and they basically make it so that we can just refer to this enumeration rather than a bunch of different developers all typing the word red in quotes. That's a very simple enumeration. A more complex enumeration looks something like this. And this is actually from a, I've modified it a bit, but it's from a final project from one of our former cohorts. So this is just a complex enumeration. So instead of red, yellow, blue, etc., it's get server time, get asset info, get tradable pairs. That, but they have arguments that you can pass with them. And these arguments are things that'll never change. So instead of you expecting somebody to pass these arguments in, when you say, you know, complex enumeration equals equals complex enumeration dot get server time, it will actually call its own constructor with the arguments that you find right here. And then it's basically like an object, and you can pass that object around. and the endpoint, the request type, the call amount, the full URL in this case will be set, and they'll be set by these arguments right here. The reason we do this because if this is something that's never going to change, so this was for an integration to a cryptocurrency API, basically. So this was the URL extension beyond the base URL, the request type, and then like the number of calls that it takes off of your like call tally. These are never going to change. And so rather than retyping these over and over and over again, they made an enumeration where they could just basically create what amounts to like an object and with these preset values. So over here, if I wanted to use it, that would be like complex enumeration, call it server time equals complex enumeration dot, I think server time was in there, get server time. So then I could say sout server time dot get call amount, get domain, get endpoint, get full URL, right? Because those are all set in this complex enumeration by these arguments right here. And these are for things that are not going to change, right? And so instead of people typing this over and over and over again, you can just tell everybody, hey, we got this cool enumeration. Now, when you want to use the get server time call, you can just say complex enumeration dot get server time. And this object, which is called server time, will have all of the right things: get call amount, get domain, get endpoint, get URL available to it. So that's enumerations. They're super handy from time to time, especially when you have things that are a limited set of things that are not going to change. And they can go from simple to complex. We're getting very close to the end. Enumerations, Lambda expressions, lambda, 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 tri-lambs. So a lambda expression is kind of, you don't really need to know it right now, but you do need to be able to read them when you see them. So a lambda expression can be, you can do the same exact thing by just using an interface, right? And with a lambda expression, you need something which is called a functional interface. And I have all these right here just in the same class, just to make it simple. Notice they're not public. If this is public, it would be an error because it needs to be in a file of the same name. So these are functional interfaces, meaning they just have one abstract method. The moment I put a second abstract method in here, test2, it's not a functional interface. So that doesn't work. So a functional interface is just an interface that has one abstract method. And with lambdas, it basically means that we can define the function on the fly. And it's a little funky, but it's different syntax. It looks like this. So numeric test, which is this name, which is the name of this functional interface, is even. So this is like an object equals. And so this is the parameter that we're going to pass in to this method. And then this is the body of the method. So basically, we're declaring the body of this abstract method test on the fly right here. So it's basically like creating a method where the body has this, and this is the argument that gets passed in. So here is an example of using, I'll put these in the right order. Numeric test. So we're creating this object called isEven. So here we can say system.println isEven, and then call that method test, which is what this functional interface method is called, and pass it a number. Then we could totally redefine it too. We could say isEven equal, and then the argument that is going to be passed in, and then the lambda pointer, and we could say, you know, this is not going to work because this is not how you check to see if things are even. But you could say n-mod3 equal 0. And then we could reuse that isEven.test and pass it 5 again. And you'll see that it'll pass, well, this time it's gonna print false. Exception. Make sure we're calling the right. Oh, we don't have a main method here. So PSVM, let's just call inline example. And we don't need to pass it any arguments. So this should print true and then false, or false, false, true. So isEven is false. And then isEven test 5, even though I changed the behavior of this lambda, so it doesn't actually really make sense. And then is negative is dot test -5. So I'll just get rid of this. Basically, this was me just demonstrating that you can redefine the body of that lambda function on the fly, which is what makes it kind of useful. Here we're creating another version. Remember, numeric test is the name of the interface right here. And we're creating basically an object out of this interface. And we're giving this numeric test has a method called test, and it takes one argument, int n. And that's that argument right there. And then here's the body of the method. So basically when we say is negative, which is this object, dot test, which is called that abstract method right here, and we pass it -5, it will run this calculation. Is n less than 5? If so, it'll return true. If not, it'll return false, right? We could change the, like really quickly, I could make another one. Numeric test is positive equal, I know that method takes an argument. So let me say n greater than 0. And then I could say sout is positive and pass it -4. And then, sorry, is positive dot test. And then I could do the same thing again, say is positive dot test and pass it the number 4. And I'm just going to comment these out so we just see the results of this one lambda right here. And we say false and true because this is not positive and this is positive. So one last example is the block lambda. I'll put this all back up here so you can see it. I'll comment out the inline example, and I'm going to hit the block example. The block is just, so let's args out of here. You can, in this previous example, the definition of the body was really small. It was just one line, so we could just do it on one line. But you can also do it on multiple lines. So here is basically just the body of that default method. So this is using the string lambda functional interface. It has a method that's default abstract method. It returns a string. It's called string func, and it takes a string. So here we're creating an object of that class, a string lambda. This object is called reverse, and we're just saying equals str, whatever gets passed in, and then here's the lambda definition of that method body, string result, and we're going to go through and basically reverse the string. And if we run this guy, when we pass in reverse dot string func lambda demo, you can see that it prints it out backwards. And I should say that I think it was Geeks for Geeks. I pulled this very quickly as an example. So shout out to geeksforgeeks.com. So inline lambda expressions and block lambdas. So block just means that you can define the body of that default method, that abstract method. In this case, it's called string func right here. But you're just defining this object on the fly. And then here is where we use that method. So the body of string func, this method right here, was defined right here. And we did it inside curly brackets because it's multiple lines. That's lambda expressions. I'm going to leave method references for a later date. It's been a real pleasure going through all this. I know it took longer than 90 minutes, but if you made it this far, great, great work. And stay tuned for part number 4, where we have a little more fun and we just build out a blackjack poker game using a lot of these new skills. Thanks for watching.